The second stage, its engine is housed in that black interstage region that's just below the 5-meter fairing, and that's what's going to finally bring the spacecraft up into its orbit. And as we've discussed already, that first stage, once it separates from the second stage, is going to head on back to Vandenberg.
Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear flight through max Q, or maximum aerodynamic pressure, and then we'll about 2.5. Strong record track has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very to the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Talk flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3. 2. 1. 0. And liftoff of Sentinel-6 Michael Freilich of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal. M1D propulsion is nominal.
Power and telemetry nominal. Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder, coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there, visible on screen now. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1, boost back burner start.
And that second engine looks like it has lit. You can start to see the engine bell there turning an orange.
Vehicles are following nominal trajectories. Separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots.
And boost back burn shut down.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. Switching between opposite sides of that second stage.
Vehicles continue to follow.
That term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard. That how do we ensure pinpoint landing? And those grid fins play a huge part in that. Second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase. We will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of, do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. All accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
A beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right. We're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, we soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210 tons of thrust once it's on orbit in the vacuum of space.
Go on, entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It was incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Tell that we were excited. We were standing there. And we saw it. It was so clear we could see the separation as it was going the entire. Isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2. And we're going to call that out. Here it comes. There it is!
Wow. Oh my goodness.
Coming in at an angle.
Oh my God.
What do you think, Jesse? That's amazing.
Oh my goodness. I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down perfectly.
perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh, we heard that.
Oh, that was
And Falcon 9 has landed at LZ4, landing operator
beautiful.
speed into 11.100 on recovery 2.
I'm a little
The
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever
and
you are.
reverberating through the valley
Oh,
here.
I know.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, you know, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
Thank you so much for having me. This has been amazing. Thank you.
Absolutely. Thank you. All right. Well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but you know, we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. Going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have their part on time and in very significant terms. The launcher we have just seen, but also very important instruments like the micro radiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there's much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Great.
Sorry, this is a little...
You're coming back to me, or...?
Yeah, we are. What would you like to ask me, so I can gather my thoughts?
It's okay.
What difference is Sentinel-6 making to revolutionizing ocean
Geography.
Okay. Still have 10 minutes. You don't have time. We got plenty of time. You'll be out after the video. You'll have like 6 minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed.
Give me a cue.
Count you down.
The altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, you know, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, you know, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, you know, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of Gnssr class altimeters, and what we expect to see a new science coming out of Sentinel-6, that it would open up new frequencies that give us a fuller picture of what do we know about the oceans. And ocean altimetry, by now, it's a mainstream tool of modern physical oceanography. So if you are a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds, or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer timescales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
Precision, which is essential because the annual change in atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Michael Freilich radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus marine services for serving maritime operations, which are essential for maritime safety. And these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Oh, well, thank you, Craig.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from the European Space Agency. So thank you so much to them. And the climate science conversation conversation continues. Tune in. Just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
This satellite was renamed after American oceanographer Michael Freilich, who led NASA's for more than a decade. Freilich passed in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the contributions of thousands of scientists, engineers, and diplomats on both sides of the Atlantic.
It's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
Certainly, he would have been thrilled to see this launch today. Joining us now is Daniel Freilich and Sarah Freilich, Michael's children, son and daughter. Thank you so much for being here.
Thank you.
Yes. Very welcome. So, you know, you just saw this launch. Your father's name is on the satellite. What were your thoughts as you were watching that?
It was gorgeous. Like, I haven't seen something that beautiful before.
It's amazing.
It's my first time seeing a launch from here, and to just see that was incredible. Like, it means so much to see and feel it. You know, like, I'd heard him talk about feeling it, and feeling that as it goes is just incredible.
Amazing.
And we all talk about him in the space community as just being such an inspiration. I had the honor of hearing him speak once as well. A man outside of the work. So tell us a little.
So our dad was passionate, and like whatever he chose to be a big part of it, and like was in all of the communities. And I like to tell people I didn't have heartthrobs on my wall. I had ESA and satellite images as the poster. And so that was just who my dad was. He shared it with us, and you know, like, he was always there.
And I think another thing is, you know, he cared about things at all levels. So not only did he care about an individual mission, but he cared about how it affected the entire world. And he did that with everyone he worked with. You know, he talked about the people that he worked with. He talked about all of the science that happened. When we were going through his papers, actually, we found that he had the science papers written about the impact on the world. So he even cared about every part of the process, the people, the science, and what it meant for humanity.
You guys were sharing a nice moment with me yesterday when you said that, you know, you have talked to the people who worked with him, guys, and then he talked to them about you. And so just sharing, you know, the mutual experiences and the real person, the real deal.
Yeah. He would push everyone to be their best in order to make everything better.
And we don't want to forget about Rosie here. This would be his grandchild, right?
His first grandchild that he got to meet, so that was very special.
Rocking the Sentinel-6 shirt. Look at that.
You know, Sarah, you're a science teacher, right? So what part of this kind of carries through to what you do today?
So I think we do a big unit on climate changing, because like for me, sea level rise and like what we can do as individuals is so important, and like I was saying, and so as much as I teach science, and I hope that each student can find something that excites them, whether or not it's like physics, biology, like rising sea levels. But I want to make sure that there's a space for everyone to find something that interests them.
And Michael Freilich had a red pen. Do you have
a red pen?
Rosie does.
Yeah. So Rosie got a red
tradition. Rosie,
yeah.
just mark it.
Important, like you said, for future generations to be inspired and make a difference.
Yeah,
Thank you, guys.
That's what he wanted us to understand, that it needed to be better for everyone. And so he always said, it's not that there's climate change, but the climate is changing, to try to build unity topic and have everyone understand what impacts they can make and why it's important to all of us.
That's very well said. Daniel Freilich, Sarah Freilich, and Rosie be here for this moment.
Thank you
it's
so
just
much.
Incredible, and thank you for sharing your father's legacy with us.
Thank you for having us.
Thank you so much for having us.
Michael Freilich believed strongly in the mission documenting sea level rise. Earth's oceans affect us all, from the air we breathe to how they impact our climate. Let's take a look at how Sentinel-6 Michael Freilich will help us continue to explore oceans from space.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. We're here at NASA's Jet Propulsion Laboratory, and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
Give a little intro.
And Josh Willis is here, more affectionately known as Climate Elvis, joined by NASA's Blair Allen for a live demonstration.
That's right, Marina. Josh is here. The king is in the building with some
Thank you. Thank you very much.
deep insight into the science of Sentinel-6. So let's start there. Before we get to the demonstration, tell us a little bit about the science behind this mission.
Well, Blair, first I got to say, that was amazing.
I know, right?
I just saw that the rocket went up and then it came back down.
Yeah.
And so did the boom. It lowered the boom on us.
It did lower the boom, even when you know it's coming.
Yeah.
It's still shocking.
Boom.
Yeah.
Sonic boom. It was cool. But
it dropped the mic on us.
It dropped the mic, as I know you were going to do at the end of this segment.
Okay. Well, let's hear it.
So Sentinel-6 is going to tell us about the sea level. It measures the height of the ocean from about 800 miles up, and it does this with an accuracy of just 1 inch. And yeah, right?
Yeah.
Pretty cool.
Yeah.
And so it does that everywhere in the world, once every 10 days. And from that, we can figure out global sea level rise, how much the oceans are rising because of human-caused climate change. So it's pretty neat.
Yeah. Now, one of our followers on Twitter, Ave, wants to know if they're twin satellites, why are they being launched 5 years apart?
Yeah, that's a great question. They're twins, but one's the younger twin.
Okay.
Okay.
Significantly
younger twin. So yes, so the idea is that we have to keep measuring sea level rise. Sea level rise is not going to stop anytime soon, and we have to keep our eye in the sky looking down on it. So we just launched the first one today. In 5 or 6 years, it'll start to age, and we'll launch the second one, and it will continue the record another full decade. Awesome. And that's a big deal because sea level rise is actually accelerating. So the rate of rise, in the 90s, it was about 2 millimeters per year. In the noughties, it was about 3 millimeters, the noughties, you know, the decade starting in 2000.
I know, but let's see the demonstration.
Yeah.
Go ahead.
Okay, yeah,
Bring
sure.
us to it. Yeah.
Okay, so, all right. What happens when you hold a flame to a balloon?
I'm going to say it pops.
That's right.
But I'm just a layman.
Well, this layman is right. Let's find out, right? Now, in order to do this, I have to put on my safety gear. So here we go.
There you go.
Now, we're gonna do this, all right?
Yeah.
And it's gonna pop, right?
Okay.
Here we go. All right,
Ready.
1, 2.
Wow.
It was terrifying, wasn't it?
Frightening.
Frightening, right? Now, what happens when you do the same thing with a balloon filled with water?
I'm assuming it pops as well, right?
Let's find out. Here we go. Look at that.
Fascinating.
Look at that. It's right there. It's right there on the balloon.
It holds.
It's not popping.
Why not?
It's not popping because water is so good at absorbing heat that it actually takes the heat away from the balloon before the flame can melt it. And that's just like the oceans. The oceans absorb more than 90% of the heat from climate change. So if we think about global warming, it's really ocean warming, right?
Wow.
That's pretty cool, huh?
That is amazing.
I'm really glad it didn't pop. You know, I was afraid I was going to have to give up all faith in science and join the circus or something.
We don't want you to do that.
No.
Well, thanks so much, Josh.
Yeah, you betcha.
Yes. All right. So science has also left the building along with Josh.
Okay.
Back to you guys at the gravel pit.
I'm going to go join the circus now. Yeah.
Okay. Well, Blair and Josh, thank you so much. I guess he's a hunk of burning balloon or something. Well, anyway, we want to recap the launch now. Just about a little more than 25 minutes ago. We launched from right here at the Vandenberg Air Force Base, courtesy of the 30th Space Force Wing. There it is, the Falcon 9 rocket and Michael Freilich spacecraft on at around 9:17 this morning, Pacific time. 12:17 Eastern time. There you see liftoff. The Falcon 9 rocket soaring into a beautiful blue sky over the central coast of California. The launch was picture perfect. Look at the shot right down the center of the rocket as it left the coast here. The mission to launch the Sentinel-6 Michael Freilich Satellite into space. And as it got up off the ground, the launch, it seemed the rocket was taking its time, nice and slow. It's a nice heavy satellite up there. But once it cleared the tower and got up into the upper parts of the atmosphere, boy, it started to race. Michael Freilich's family were on hand to watch the launch, and it was just an incredible sight to behold. A wonderful a time had by all. We had guests and friends and relatives of Michael Freilich out here to watch it. And then just a few seconds later, about 8.5 minutes to be exact, the booster came back down to a nice soft landing. Just several hundred feet away, there came the booster touching back down on the landing pad. SpaceX now able to reuse that booster. And now the spacecraft is in flight, and we are tracking its progress. Joshua Santora and Philip Hargrove are keeping an eye on the progress of the launch.
Oh, that was just...
That was something, wasn't it?
Inspirational.
It's incredible.
So beautiful. All right. Well, there are more than half dozen international partners on the Sentinel-6 mission.
Yeah, the European Commission paid to build the satellite earlier, but we spoke to the Europe's ambassador to the United States, Stavros Lambrinidis, about its importance to Europe. Ambassador Lambrinidis, thank you so much for being with us.
Thank you for having me.
I want to ask you, first of all, how important is the data that comes off this satellite for the continent of Europe?
It's supremely important because as we are coming out of COVID and we're trying to rebuild our economy and the health of our people, we're doing so by protecting the climate and protecting the environment. Climate change is an existential threat for all of us, and we need all hands on deck to address that challenge. And, you know, today what we saw is an exemplary story of European and American friends working together for the greater good. For Sentinel-6, we pulled together our best engineers, our best scientists, our best resources. We mobilized the public and private sectors to produce the most advanced ocean monitoring data in history.
With that thought, I want to ask you on a personal level, what is the significance of this launch for you?
Well, I'll tell you, as the EU ambassador, I am proud. I am deeply hopeful for the future of our planet, and I am touched. I am proud because Sentinel-6 is at the center of the European Union's Earth observation program, which is called Copernicus. And I'm especially proud that we are making this decisive scientific move in partnership with our American friends.
Back to the partnership. Sentinel-6 Michael Freilich is actually NASA's first direct partnership with the European Commission. So take me back to the beginning. How did this all come about?
Well, it all came about from a remarkable success story of European cooperation, first of all. So Copernicus came from a cooperation between EU institutions and intergovernmental agencies such as the European Space Agency, the European Organization for the Exploitation of Meteorological Satellites, down to national space agencies and the industry. So this was first and foremost a European success story.
And now that satellite has been launched into space, and we look forward to getting all of that data for the better of the entire world, really. Ambassador Lambrinidis, thank you so much for joining us today.
Thank you. Thank you very much.
Meteorologists understand the critical importance of advance warnings of severe storms across our nation. One of the instruments aboard Sentinel-6, the Global Navigation Satellite System Radio Occultation, or GNSS-RO, will be the next tool for more accurate forecasting. Let's take a look.
Sentinel-6 Michael Freilich will provide important information in producing our daily weather forecast. So how does this work? The data from the GNSS-RO, that stands for Global Navigation Satellite System and Radio Occultation, a new instrument on board, is ingested into the weather models that can help us with our weather forecasting and our warnings to help protect the public.
This mission will use a special technique called radio occultation, which measures tiny changes in the radio signals broadcast by GPS and other navigation satellites. The GNSS-RO instrument essentially measures the time delay of the radio signals as they go through different layers of the atmosphere. So this allows us to unravel the temperature and moisture content of the atmosphere layer by layer.
Most of the weather that we experience comes from our west over the ocean that lacks conventional observations like what we have over land. The GNSS-RO will help address these challenges by providing us very important temperature and moisture information over the ocean that will help our forecast here on the West Coast.
Studying the entire atmosphere, from the surface all the way up to the stratosphere, is important for us to improve our understanding of our weather and climate change.
We're very excited with the data that the GNSS-RO will provide for these weather models that will ultimately help improve our forecasts and warnings to help protect the public.
Eric Louliette is the NOAA, the National Oceanic Atmospheric Administration's program scientist for Sentinel-6. NOAA is one of the Sentinel-6 partners and will use the data from this satellite on a daily basis. Thank you so much for joining us, Eric.
Thank you. It's a really exciting day to see that beautiful launch.
Oh, it was so spectacular. How will Sentinel-6 help meteorologists at NOAA and across the nation? The GNSS-RO instrument will provide a temperature and humidity profile throughout the atmosphere, which is pretty awesome.
Yeah, indeed. We're very excited at NOAA to be using data from all of the instruments. We'll be using from the radar, measurements of winds and waves that will go right onto forecaster screens. We'll be using the sea levels to improve ocean current forecasting, which will help for navigation. We'll also be using those sea levels to measure heat content, which is really important for sustainable fisheries. But as you also say, we saw from that last video how we'll be using the GNSS-RO instrument to profile the atmosphere, measuring humidity and temperature in the layers. And that'll help us do all sorts of improvements to forecasts, including using the atmospheric measurements to monitor hurricanes from their formation all the way through their whole life and dissipation.
And Eric, we have seen great improvements in forecasting hurricane tracks over the years, especially with the launch of Goes East and West. But how will Sentinel-6 help with forecasting the intensity of these storms?
Yeah, one of the reasons that hurricanes can become intense is because they feed off the energy that's stored in the upper layer of the ocean. As you saw from Josh's demonstration with the balloons, the water in the upper layer can store a lot of heat. So what we can do with Sentinel-6 is by measuring sea level, we can measure how much the sea level has expanded. That's a proxy for how much heat there is stored there. So we can figure out how much heat and where it is and map it and send those maps to forecasters. This year alone, we've seen 10 tropical storms increase in intensity rapidly. So it's more important than ever that we have Sentinel-6 there for the next decade to monitor and improve hurricane forecasts.
Yes, ocean heat content is so important. I always like to think about it as a car that needs gasoline. A hurricane needs that warm water to fuel that engine, that's for sure. Now, what impacts to society do sea level changes have, and how will Sentinel-6 help us better plan and prepare for the future, Eric?
Sure. For the last 30 years, we've been seeing sea levels rise using the satellites that are the predecessors to Sentinel-6. And one of the things we've learned is that sea level doesn't rise at the same rate everywhere. So it's vital that we use Sentinel-6 to map where the sea levels are rising. We've already started seeing flooding both in clear weather from places all the way from Hawaii, the Florida Keys, to Norfolk, Virginia. So we're going to need Sentinel-6 and working with our NASA partners to help make better models to figure out where we should expect increased flooding and storm surges as sea levels continue to rise.
Thank you so much, Eric, for joining us today.
Thank you.
Another fantastic tool on board is Sentinel-6 is the Advanced Microwave Radiometer for Climate, or the AMRC. And the person who led the testing and integration was JPL's Shannon Statham.
In order to be good custodians of our planet, we really need to understand how it's changing. How is it evolving? And here we are at High Bay 2. This is actually a clean room, and each component gets tested on its own, and then we assemble it together. So my team was responsible for assembling, testing, and delivering AMRC for the Sentinel-6 mission. And this is where we built it. AMRC is the Advanced Microwave Radiometer, one of a suite of instruments that work together on Sentinel-6 and then give us the very high resolution heights of the oceans. So we are in the antenna range at JPL, and this is where we tested AMRC. We need to know that what we send into space is going to survive. I've always had an affinity for arts, singing and dancing, and so one of the things I've been doing more recently is sewing. And my dress, I actually sewed. You cannot do this job without being creative. Every mission is unique. We are answering those really interesting and hard questions that we all have about our universe and our planet.
Shannon Statham joins us live now on this exciting day. Boy, what a textbook launch. Welcome, Shannon.
Thank you so much for having me.
Yeah. Now, you work on the Advanced Microwave Radiometer for Climate instrument. Now, what is the exact role of the AMRC?
Yes, so AMRC works in conjunction with the Poseidon radar to get those very precise measurements of our sea level heights. And effectively, AMR is looking at water vapor in the atmosphere, so clouds and rain and snow. And that affects the radar measurements because it basically causes a delay in the signal returning back to the radar. So ocean heights might look a little closer or a little further away due to those effects. So AMRC, we take the data from AMRC and we're able to resolve those effects out of the data and then get those very precise measurements.
We're in the super science part of our show, by the way. We're really hitting it hard. This is great. I want to ask you, you also do testing, right? Because this thing helps with accuracy, but you've got to test it to make sure that it will be accurate. How do you test for mission and launch environments?
Yes, so at JPL, we have a number of facilities that simulate launch and the extreme temperatures and vacuum of space. And so everything that we build is going to go through this test campaign where we certify it for launch and we certify it for its space environment, and not only ensure that it will survive, but that it will perform the way that we need it to throughout the mission.
And the AMRC instrument, Shannon, I know we've talked about this before, it is much more difficult and complex than its predecessors. And so you didn't really have a blueprint on this one. How is it different?
That's right. Yes, well, for every mission, we're going to, push that envelope, try to use the latest technologies, and AMRC is no exception. So we have two new components on AMRC compared to the predecessors, and that is a high-frequency component that enables us to get more precise measurements near coastal lines. In past missions, as we're over the oceans, we see really precise heights, but as we got to the coast, things were a little blurry. So now we're going to be able to get those better measurements near the beach, which people care a lot about because that's where they live and that's where they have businesses. And we also have an onboard calibration system, and that includes a rotating mirror. So of course, just adding to that complexity. And that was because of some new science requirements on Sentinel-6 to get us even better data throughout the mission.
And folks in Florida certainly care about that because there are more There are more miles of populated coastline in my home state of Florida than in any other state. Got a question from social media for you.
Okay.
Hank reached us from Facebook, and he wants to know how accurate is the satellite? What is the smallest area of ocean it can measure the altitude of? And might it have any applications for detecting seismic activity?
Oh, a very interesting question. Yes, so for a single measurement, we can get down to 3 centimeter accuracy. But as we continue to take those measurements, we get global coverage over a 10-day period, and then we continue. We continue to get the map of the full of our full planet and all the oceans. And so over the span of a year, we get down to millimeter resolution. So that's an order of magnitude better than a single measurement, and how we're able to get those global averages of 3 millimeter height increase per year, which is really, if you think about over the span of a decade, that's a centimeter, and over the span of a millennia, or a century, that's going to be 10 centimeters. So we're definitely seeing the rise and definitely seeing the sea level impacts.
Real quickly, the seismic activity?
Yes, the seismic activity. So although Sentinel-6 is not going to be trying to detect seismic activity or tsunamis, which often come as a result of that over the oceans, but we have been able to detect them in the past. Previous missions have been able to, but really what we're going to see is any changes in the sea levels as a result of that seismic activity and any tsunamis.
Very helpful. That's all data that is very important to our world.
It is.
Shannon Statham, thank you so much for joining us from JPL.
Thank you so much for having me.
Yep.
Thank you, Shannon.
All right, all of these highly accurate Earth observing instruments were installed onto one satellite that will orbit our Earth for about 5 years.
NASA's Blair Allen asked Sentinel-6 project manager Parag Vazay to show us how they did it.
Joining us now is Parag Vazay. He's the NASA project manager for Sentinel-6, and he's going to talk about a few particulars on the spacecraft. But Parag, before you do, I was wondering if you wouldn't mind talking a little bit about the science behind this, altimetry.
Yeah, altimetry is a science. It's basically using microwave instruments, using them from space so that we can cover the vast oceans that we have across the whole world. And the whole objective with altimetry and ocean altimetry is to be able to measure those oceans across the world, measure them very precisely. And doing that with a satellite from space allows us to do it completely and most accurately that we can all across the whole world.
So let's look at the instruments. Can you tell me about the primary instrument for Sentinel-6?
Yeah, the primary instrument is the Poseidon radar altimeter. It's built on a simple concept, which is like any other radar, where basically we are producing a radio signal from the instrument. It's being transmitted down to the Earth from space, and we're waiting to actually get the reflected signal off the ocean surface back up to the antenna and receiving that signal. We want to understand how long it took for that signal to get it back here. And then with that, we're able to understand what and measure what the height of the ocean is.
And there's another important instrument on board, the AMRC. Can you talk about that and its purpose?
Yes, you're right. This is the Advanced Microwave Radiometer, a very important instrument for doing this measurement, because the Poseidon altimeter measures the height, but it really matters how well that is measured as that signal passes through the atmosphere.
And we need the microwave radiometer to be able to measure differences in that signal as it passes through the atmosphere. This instrument provides us that correction so that together we're able to make a very precise height measurement of the ocean surface.
What are some other important features or instruments that are flying on Sentinel-6?
Yeah, we're lucky because on Sentinel-6 we do have an additional instrument which is called the radio occultation receiver that's right here with the antennas that you see here. It's a totally different concept, but similar in some sense, where we're actually trying to measure how radio signals bend through the Earth's atmosphere that we get actually from other satellites. So we use signals from the GPS constellation, which is transmitting a signal, and these antennas will receive it through the atmosphere, help us understand what the atmosphere is like in terms of temperature and humidity.
Well, we're very excited about the spacecraft and obviously the data we're going to get with Sentinel-6. Thanks so much, Parag, for being on the show.
Thanks, Blair. As we have mentioned, Sentinel-6 is a true international collaboration among several agencies around the world. It was built upon a legacy of Earth observation missions. Let's break down how this partnership came together. The Sentinel-6 Michael Freilich Satellite is the culmination of decades of international research and development of satellite altimetry designed to measure sea surface height. In the early 90s, NASA and the French Space Agency launched Topex Poseidon, the first in a series of next-generation altimetry missions that includes the Jason satellites. Meanwhile, the European Space Agency created their own successful Earth observation program called Copernicus, which includes the Sentinel series. In an effort to maximize the technology and